Today we're going to look at section 2.7, graphing absolute values. Our objectives are to graph an absolute value equation, to write the equation of the absolute value equation from a given info, and to solve for unknowns given an absolute value equation. So what is the standard form for an absolute value equation? Well, it's right here. Y equals A times the quantity of the absolute value of B times x, quantity x minus C, and then plus D. I've separated the A, B, C, and D because later on when we deal with equations, knowing them separately is going to be very useful. Some books just write Bx minus C without the parentheses, but I'm going to use B and C separately here to help us with some movement later. Our parent function, just like we have with lines, the line parent function was y equals x. It was the most basic line. For absolute value, our parent function is y equals the absolute value of x without A and B being any other variable but 1, C and D being 0. So the important parts of an absolute value graph, and you probably remember some of this from algebra. So here's an absolute value, and hopefully you remember it looks like a V, either facing upwards or facing downwards. Our most important point is right here, and that's called the vertex. Okay? And these are just two rays, if you remember from geometry, extending outwards. And the slope of both these rays are going to be equal, except one side is going to be positive, one side is going to be a negative slope. Likewise here, here's our vertex. One side is going to be positive, the other side is going to be negative, so it flip-flops when it's upside down. So the things we care about is what direction does it face, we care about our vertex, and then we're going to care about the slopes of our sides of our absolute value. So what does the A tell us? If we look at this equation, the A value is right here. The A gives us two pieces of information. One, it tells us the direction. Okay? So if A is positive, it faces up. If A is negative, it faces down. Okay? It's very similar to a lot of the things we do. When we get to quadratics, you're going to see this similar thing. Okay? It also has to do with slope, and when we get to the slope part, we're going to see how it relates with the B value. But just by itself, A is positive faces up, A is negative faces down. To find slope, if we think about a line, and granted this is not a line, but if we think about a line, slope we find in front of the x. Well, technically we have the B in front of the x, but we also have this A value. So to find the slope, and again, remember they're exactly the same except one is positive and one is negative. We're going to do A times the B value. Okay, so whatever A is times the B, we can just multiply those values. We don't have to worry about the signs because no matter what, our final answer is going to both be positive and negative. So if we multiply A times B, we get the slope. To find the vertex, which is just our point, our vertex is C, comma, D. And that's our vertex. And a vertex is a point. Now, C is behind the negative sign. So if we think about that, it's like what we did when we did point slope form. C is here, and then D is whatever's behind the positive or plus sign. And there's our D. So let's think about how we're actually going to graph this. So let's first look at our equation and see if it's in the form we want. So we have y equals, here's our A value. So that's our A value. I don't see parentheses, but what can I factor out of here? I could factor out a positive 1, so that's my B value. I'm still left with x plus 3, so 3 is my C value. And minus 4, okay? So if I think about this as plus a negative 4, this is my D value. So if I actually want to graph this, I first want to start with my vertex. And I know my vertex is C, comma, D. Okay? So, but if we remember, this said x minus C. So this is really x minus a negative 3. So we do the opposite sign. So my vertex is going to be a negative 3, okay, and a negative 4. So whatever's behind the minus here and whatever's after the plus. So I'm going to go to negative 3, negative 4, put a point. The next thing I want to know is our slopes. Okay, and we're going to have one positive and one negative, and I have to take the A times the B. So if I think about this, A is 2, B is 1, so my slope is just plus or minus 2. But how do I know if I'm going up or down with my slope? Well, if I look at the A value, it's positive, so I know this is an upward-facing absolute value. So that means I'm going to go up 2, and then left and right 1 for my positive and negative slope. So let me change the color to make it a little easier. I'm going to go up 2, right 1, up 2, right 1, up 2, left 1, up 2, left 1. And I'm going to do this all the way across, just to be more accurate, to the left and to the right. And now all I'm going to do is connect these with 2 rays. It's a ray and not a line because it only extends in one direction. And there's my absolute value graph. This one gets a little bit more complicated. So let's think about what we have here. All right, so let's just look at the direction first. This is negative, so I know it's a downward-facing absolute value. I know my vertex, okay? But now I look here. This isn't in the right form, so I have negative 3/4. Let's just kind of rewrite this out. Absolute value. I'm going to factor out an 8, which leaves me with x minus 5. And then I have a plus 7. So my vertex is 5. We do the opposite sign, comma, and whatever the value is out here, 7. So I'm going to go to 5, 7. And now I have to find my slope. My slope is going to be plus or minus whatever 3/4 times 8 is. Well, 3/4 times 8, if I put this over 1, is 24 divided by 4, which is plus or minus 6. And again, remember, this is facing downward. So what that means is I'm going to go down 6 and then left or right 1. So down 1, 2, 3, 4, 5, 6. And then left and right 1. And then again, down 6, left and right 1. And then down 6 is kind of off my paper. Left and right 1, and then connect my line. So this has got a steeper slope. So let's go on to the next example. Here, this one looks a little bit different. Okay, I'm just going to write it in our standard form just to make it easier. This is a negative 1. And this isn't not in the correct order. The x's aren't first, which can make it a little bit more difficult. So I'm going to put the x's first. I'm going to factor out a negative 2, which gives me an x minus 3. Careful with the double negative. And then plus 4. I know this is going to face down. My vertex is going to be a positive 3 and a positive 4. And my slope is going to be plus or minus, what's 1 times 2? 2. Because this faces down, I'm going to go down 2 and then left or right 1. So I'm going to put my vertex at 3, 4. And now I'm going to deal with the slope. I'm going to go down 2, right 1, down 2, right 1. I'm going to keep doing that for the one side. And then I'm going to go in the opposite direction to the left, the other side. You don't have to be this detailed and go all the way through. Just makes your graph look a lot nicer. And if this is a graph where there's a word problem associated and you need to be accurate, if you just do a couple points and draw a line, it's going to be really hard to tell your answer. Let's look at D. Again, I'm going to go through, kind of analyze my equation. So I have y equals. Now, all of these could be in function notation too, where this says f of x. I'm going back to y, just so we have it, but I have 1/2 as my a value. I'm going to factor out a 6. Now, this will be a little bit more difficult. But when you factor something out, it's like division. It is division. So if I take 9 and divide it by 6, I'm going to get that's reduced to 3/2. Okay? And then minus 5. Okay, so this one isn't as nice, but I know it faces up. My vertex is at 3/2 or 1.5. That might be easier to graph, comma, which is going to be the opposite sign. So negative 1.5, comma, negative 5. We're going to do the opposite of what's in here, and then write exactly what this is. And my slope is going to be a plus or minus 1/2 times 6 is 3. So it's going to be a little more difficult to graph because I have a decimal, but I'm going to go back 1.5 and then down 5. Okay, and then from here, I'm going to go, because it faces up 3, and then left and right 1 each time. So if I go up 3, 1, 2, 3, but right 1, I'm actually in the middle. If you're in the middle this time, you're going to be in the middle every time. 1, 2, 3, halfway, 1, 2, 3, and then so on. Do the same thing going to the left. Okay. I can connect my points. And there's my absolute value graph. So now let's think about how do we write the equation of the absolute value from given info. So it's downward facing with a vertex at 4, -3. Okay, so I know this is the opposite of my C when I substitute my equation, and this is my D value. I know my slope is of 4/3, and it's downward facing. So just so you know, there's a lot of different ways to write the solution to this. I'm going to pick the easiest way to show you. So I know it's y equals. Now I know my slope is 4/3, and that's A times B. The easiest way to get an A times B, let's make B be 1 and A be 4/3. So A is going to be 4/3 and B is going to be 1, because 4/3 times 1 is 4/3. But if it's facing downwards, I know this has to be negative. And now I can just deal with the C and D. Because it says a 4 for C, I know it's x minus 4. And because it says a -3 for D, I can write plus -3 or just write -3. You might see the answer written like this, or you could just see it as x minus 4 minus 3. Both of those are okay. They're the exact same answer. What if we have an upward-facing absolute value with a vertex at 0, 8, so this is my C value, this is my D value, and again, A times B has to equal 7. It's always easier to make A 7 and the B 1. So, I'm going to write y equals, my A is going to be 7, it's positive because it's upward, okay. My B is going to be 1, okay. And because we're always going to make B 1, you can just skip this step of writing in here because it's always implied that it's a 1. X minus my 0, and then plus 8. We usually wouldn't write that. We have a lot of redundant stuff in here. So I'm going to write y equals 7, and then really this is just x plus 8. This would be the best way to give that answer. So what if I give you a graph? They basically get the same information. You just have to count a little bit more. My vertex is at 5, 3. I can obviously see that's going upwards. But now for my slope, I have to count. Doesn't matter which direction I count, I'm going to go up 1 and then right 3. So up 1, right 3. And the right-hand side is positive in this case, the left-hand side is negative. So again, A times B, I'm going to make my A 1/3 and my B 1. So I'm going to go y equals. It faces up, so I know A is a positive 1/3. I'm not going to worry about that 1, like I said, because it's always going to be there. I'm going to do x minus 5, because the C is a positive 5, and then plus 3. And that would be the equation of my line, my absolute value graph. So let's look at a couple word problems. A raincoat retailer has modeled the number of raincoats sold from January to December by the function r equals -1/3 times the absolute value of t minus 6 plus 15, where t equals 1 represents January. What month has the most raincoats sold? You might think, well, how would I have any clue of that? But I know what shape this is. I know this is a downward-facing absolute value graph. It's downward because this is negative, and it's absolute value graph because it's an absolute value equation. So where would be the most if this represents the number of raincoats sold? Well, right here would be the most, which is my vertex. And we should be able to find the vertex easily from looking at this. I know my vertex is 6, 15. So if it asks what month has the most raincoats, well, t is my time. Okay, so this is my time, because you're not using x, and this is my number of raincoats. So I know that there was 15 raincoats sold in T6. Well, if t equals 1 is January, because January is the first month, what month is the 6th month? Well, if we go through that, June is the 6th month. So what month has the most raincoats sold? That would be the month of June. Okay. So now they ask a follow-up question. They said, how many were sold in October? So if I want to know October, what I'm looking for is month 10. And I want to know how many raincoats were sold. So this is my T value, and I'm looking for the R value. Well, I have a nice equation where it says the number of raincoats is equal to -1/3 times the absolute value of T, which is 10, minus 6 plus 15. I'm just going to do a little bit of algebra. -1/3 times 10 minus 6 is 4, plus 15. So 1/3, absolute value of 4 is 4. So I'm going to get 1/3 times 4, which is 4/3 plus 15. Well, that seems kind of weird because this is 1 1/3. So this is 16 1/3. Now you can't sell 16 1/3 rain jackets. Because remember, this just models it. So this is getting us as close as possible. It's like when we did linear regression, the line wasn't exact, it just gave you a nice model for what it would be. So what you could say is that it sold approximately 16 raincoats. Okay. Let's try one more. The population P in thousands, and this is always important, we've done some of these in class, which kind of makes it a little bit more difficult, of a town can be modeled by, and again, it's just modeled by, it's not exact, by P equals -2 times the absolute value of T minus 4 plus 10, where T equals 0 represents the year 1990. In what year or years was the population 6,000? So this is the key. This is population is 6,000, but they're telling me that in this equation, P is already in thousands. So what that means is how many thousands do we have here? Well, we have 6,000, so P is just 6. If I put 6,000 in here, the equation would think I would have 6,000 thousands, which would be 6 million, and we definitely don't want that. So what I'm going to do is substitute in 6 into my p-value. And then what I'm going to have to do is solve for t. Now this is a little bit more difficult than the last problem because this is solving for an absolute value, which we've done in class already. This is what we did in section 1.7. So what I'm going to do is subtract 10 from both sides and get a -4 is equal to -2 times the absolute value of t minus 4. I'm going to divide both sides by a -2. And typically I'd have to worry about dividing by 9, but remember this is not an inequality, it's an equation, so we don't have to worry about the negatives. It's going to be a +2 is equal to the absolute value of t minus 4. So remember what absolute value means. Absolute value is asking, they're telling us that the distance away from 0 is 2. So again, if you are 2 away from 0, my only options are at +2 or at -2. Those are the only two solutions that work. So what I need to do to solve for t is t minus 4 is either equal to a -2 or t minus 4 is equal to a +2. Those are my only two solutions. So t is equal to, if I add 4 to a +2, or if I add 4 to this side, t is equal to 6. Remember, t is my time, where t equals 0 is 1990. So t equals 2 is 1992, and t equals 6 is 1996. So when they ask in what year or years, we actually get two answers. It would be in the years 1992 and in the years 1996.